Welcome to the tutorial. This tutorial is for students of the module TT284 who want more insight into the workings of the web application, the part 6 solution. Note that there are many ways of writing code that can produce the same result. The code here is designed to be easy to read rather than efficient. As you develop your programming skills, you will encounter other styles of programming. I'm going to start by cleaning out all the files from my Block 2 folder, except for the utilities that I want to keep and my database.php, which contains the passwords and username for the database. I'm going to start by using the update and display code utility, and that will allow me to drag the files that I need in. On Chrome, I should be able to select them all and drag. And now if I refresh this, I should see all my files are now listed. In order to start this part of the assignment, I need to first of all create my test table to give the program something to work on. You can see that I've got various tables already in the database. It's telling me that my test table has now been created. If I run this again, by refreshing it, you can see that my test table is there, and that's the table we're using for this demonstration. I can now run the core admin. I can run it here, which will run on its own. If I go back, I can run it from here, and that will run within my utility. At the same time as I can see it running in this window, I can also look at the code with syntax highlighting. Now let's look at this code to start with, and what we've got is a core to the application. It starts by creating our web data array. It creates a number of variables, including my table, which is my test table, which we've just created, a title, the CSS link we're going to use, the JavaScript link we're going to use, a variable that's setting valid to be true, and then we have a series of requires. It's useful to check that you've got all these require files loaded into the folder, because if these are missing, it's not going to work. Using require files in this way avoids having a single monolithic program. It's easier to read if we have individual sections, each of which have a specific purpose. So my database PHP is simply the database username and password that we'll be using, and that database contains the table that we have created. Notice further down that if valid, require save the data. If the action is confirm delete, we require delete data.php. So we are using valid to decide which of these other files are going to be required. We're not simply loading everything every time. We're only loading these required files as we need them. And again, we've got requiring the form, requiring the display data, requiring search and sort. Here, if we have the action of search, then we require the file that handles this search. We don't need that if we're not doing a search. And at the end, we require the footer. So there's a little bit of logic takes place in this core script, but this core script is really joining everything together. So it's when we go into the separate required files that we'll see the details of what's going on. As we said before, we've got one script that does the connection, another one that sets up the array, another one that creates the forms. When we're trying to understand how a script works, we need to be able to compare what's happening in the form here with what's happening on the script. Now, as the scripts are running, they're echoing aspects to help us identify what's taking place. So we can see that core admin is running at the start of the script, connecting to the database. We've connected to MySQL. We're setting up our arrays that we will use within the scripts. It's reported that it's created this. So we are actually echoing here back to the screen information that's useful in understanding what is going on in the program. This next section is reporting back what has been sent to the form data that is running. It's collecting the data from the post variable and copying it to our web data array. The web data array is where we would do the processing if we wanted to process data, to validate data before we save it in the database or use it for other purposes. The input form is then being generated using that data, and it is checking to see if we're editing an existing record. Note that there are aspects that we're not actually doing in this script. We're not authenticating users. A real application would always authenticate and authorize before allowing a user to do anything on the server. Further down, we've got the data entry form into which we can create a new record. We've got a section that we can display that will show us the data that's already in our data table. And at the moment, there's nothing there. And when there is data, we'll be able to search a form to enter to do a search, but as we've just said, there's no data yet in that database table. So this is up and running. Let's just put some data into the form. A test, B test, and we can see the validation in action, changing the color and confirming with a tick, just to confirm that it's actually reading the data. It's writing it back here again. Email, again, we have to have the correct format for an email. test@test.com, telephone number, and it's now saying it's ready to submit. So we're simply filling in a standard form here, but we've got validation taking place that we'll look at later on. And when we submit it, it submits this to the server. Next, we'll look at the code that produces the data entry form. We can identify it in c_form.php by the heading here, heading 3, data entry form, which matches the data entry form text in our browser view. Just before that, we've got the code that shows and hides this section. The form has a method of post. Its action is to server self. This writes the same name of the file into the form so that if we submit from this form, it's sent back to the same file on the server. And on submit, we are going to validate this form contents. The return ensures that it doesn't submit if it's not valid. We have a label for the first name, an ID of first name, a placeholder, required, maximum length of 30 characters and a minimum length of 1 character. This max length and min length are HTML5 validation. I want to note next that the input for the first name and for the other elements in the form contains a value, and the value starts here and ends here. It encloses a section of PHP code. If valid, and valid is our flag that content from the form is valid, it'll echo the row of data that has been saved to the database. If it's not valid, it'll display the web data array for this form value. Now, the reason for this is because forms are being used in 3 different situations. Firstly, to create a new form. If the web data array is empty and we're not trying to edit anything, then web data will be empty and the value won't be anything. It'll be null. If we submit data to the server and the server reports that the data is not valid, it's going to represent that form containing the data that's being submitted, ready for it to be edited by the user. And the third case is if data needs to be edited, in which case we'll be using a row of data from the database, hence row first name. These make the input value slightly more complicated than on a static form. And you will see this PHP code repeated for each of the elements. First of all, if that item is empty and we're creating a new form. Then if the server says it's not valid and we're sending the data back to be re-input or edited. And thirdly, if we're editing data, we're using the same form and inserting into it the data that we want to be edited. Now if we look down the code for our form, we can see this sequence of PHP code being repeated for each element. So here we have the last name input. Here is the start of the value. Again, we've got if valid, else if not valid, ending there. And if we scroll down, we can see again value, label for email if valid, ending there, label for telephone. If you are adding another field to this form, you will also need to give it a section of PHP code. If it's an element that takes a value, this section of code will fit within the value. But if it's an element that doesn't take a value, you'll need to check with the element to see where this section of code should go. Not all elements have a value. JavaScript validation of each of these form elements starts with an onChange. So when the content is changed within the field input box, it calls my function and passes to it the ID of this particular element. It also passes the value, and as is a flag that we're using to identify the type of validation to be used in the JavaScript. The element is followed by a span. The ID is the same as the ID of the element. So here we've got ID is first name. Here we've got an ID of FB first name. And we're adding FB in front of this again to have a common pattern that establishes a relationship between the element itself and the ID span into which feedback for that element goes. This means we can use a general purpose function rather than having to have the same function operating each time. So when the element has some content, if we click on this, bring it to the front, I can put in a name, and onChange fires when I move away and click somewhere else. This is the span into which the JavaScript is placing a tick, and it's actually repeating the value to show that this is valid. So the same pattern operates in each of these elements. If you add another element, you need to use the same pattern to identify the relationship between the ID of the field and the ID of the span into which feedback goes, and in our particular example we're using FB each time. Here we have FB first name, next one FB last name. It's the same pattern that establishes the relationship between these two. At the end of the form we have a hidden field called EditID. Again we have a value which encloses a section of PHP code between these 2 points. If data is valid, we echo the row ID of the data that has been saved. If it is not valid data that's been returned to the server, we echo the value of the web data EditID. This means that if we are editing data, this has been set in a hidden field. This is then returned to the server, and if it again is not valid, this value is retained and sent back to the form again as a hidden field. So this tracks the ID. Now, in a live situation, you wouldn't want to actually use the ID, because that could be altered by a user or a hacker in order to return data with a different ID from the one that is intended. So in a live situation, we might use a hash of an ID, and when this comes back to the server, we will compare that with our real ID and only allow the update if the ID and the hash match. It would need to be a hash with salt again to prevent a hacker trying to identify the type of hash that's been used and to duplicate that as well. So it is this hidden field that allows the form to be used to edit data, to enter new data, or to correct data that has been wrongly entered. Another section of this form script produces the form that's used to confirm delete of existing data. Again, the form action is back to the same script. It echoes the row ID that is being deleted or being offered to be deleted. It contains a hidden field with the ID of EditID and a value into which PHP is echoing the value of the ID from the row of data. Another hidden element that is the action, which will be confirm delete, and a delete button. On this delete button, we have the first name and the last name displayed to the user, so that it is clear what they are able to delete. And that ends this form. When we search the table, we can enter any combination of search terms into these columns, and I'm just going to search on the letter T. And because I've only got one entry, but it has a T in it, that has come up. And this includes a small form that allows me to select this particular row for editing. If I click on that, here we see the contents of this particular record that has been selected from the database, entered into the form so that they can be edited again. And as you can see, these are all valid entries. If we go to the script again, the edit button identifies this value, submits this value. We then select the columns that we want from my table, and we use bound parameters again to add the data that came from that button. We select this row from the table of data as an associative array, which means we can use the column headings to identify each element of data. And we can see them here inserted into the form that we discussed earlier. Next we'll look at the process to delete. At the same time as we've presented the form for editing, we've also provided a form to delete the same record. If you click on this form to delete, it doesn't delete immediately. You're asked to confirm the action, so you've a chance to check before you delete it from the database. Once it's been deleted, we don't know which ID will be wanted next, so the form is now empty again and can be used to enter a new record, or you can search for another item. If we look at the script that's used here, we're echoing the web data EditID so that we are identifying the row that's being deleted to the user. We use the value of EditID also to identify the row to be deleted from the table. We're using our bound parameters, so we put the question mark and it's replaced by the value of web data EditID. Remember, in a real situation we wouldn't be deleting it directly using the ID. We would be using a hash plus salt to identify the ID. The ID might be used alongside it, and we would only delete if the hash plus salt returned from the form matched the ID. So this prevents the hacker from deleting. The JavaScript validation uses a general purpose validation script that can be adapted to any form that needs validation before it's submitted. This particular script starts by setting variables for the regular expressions to be used for validating a telephone number, landline, mobile telephone number, postcode, email, and so on. You could add further elements to this. We set a variable that's used if the entry is valid, and the feedback message to be used if the value is not valid. Initially, this particular script is setting the form check values to be E. It might be a better idea to use true and false for these values. The types of validation to be used, this identifies the regex, the regular expression to be used, is set for each of our form element IDs. So we've got first name, last name, email, telephone, and you can see here that the validation type of AS is being used as a label for any string. If it's reg, then it's going to use the regular expression check, and this is where the validation is controlled. We also have a date time validation, which is not being used by this form, but it's there in the script if it was needed. The check returns either true or false, depending on whether the check passes or not. If it's passed the check, the background color, the style of that element, which starts FB, and remember how we said that we had a span after each element, and the ID of the span was the same as the ID of the form element with FB added, and it changes this to light green. If you want to change it to another color, then this is where you would need to make that change. And to the inner HTML of that span, it writes the feedback for that element. So if it's true, it's going to be writing the true feedback. If it's false, it's going to be writing the false feedback. And we've also got it setting the background color back to red if there's not a match. So we're giving feedback on change from the elements. It's being checked according to the patterns demonstrated here, and this is where the color changes and the messages are set depending on whether the feedback is true or the feedback is false. Here is the same for the AnyString check. If it's true, it's light green. We write the inner HTML. If it's false, we're writing red. Now, at the same time as we're checking the individual elements, we're keeping a record of each element so that when we've come to the end, we know whether all form elements are true, valid, or false, not valid. And we can use this to change the value of submit, not ready to submit if the result is false, or green and ready to submit if the result is true. So we're not checking each individual element again on submit. We've already checked them as they were entered and kept a record. Validation on the server takes place within this validateData.pht script. We're starting by creating an array element to record the form error for each of the elements from the form that we want to check, and setting these to be empty to start with. We're setting valid to be true at the start, but if we find an error in any of these form elements, we will set that to false, and that will trigger the data to be returned to the user in their form to be checked or edited again. If we have a value for the first name in the array, we're using a regular expression again to see if it matches. So any alphabetic character A to Z, capital, lowercase, between 1 and 30 characters long. If this is false, the exclamation mark there indicates that we're looking for a negative result. If it's false, then we set the warning message that will be displayed alongside this element on the form. And valid is then set to be false. So everything will now be returned to the form. Same pattern for last name. If it's false, this is the message that will go back to the user. So for example, if they used a number in the surname, it would not be valid, only letters and white space allowed. So we're being helpful with the information that we send back. If it's email, we're going to use a PHP function to check for a valid email, which is filter valid email. So not using a regular expression here, but a built-in function of PHP. Again, we're looking to see if it's false, and if it's false, not valid on server, and we set valid equal to false. Telephone, back to a regular expression, and here we've got 8 to 12 characters. We've also got a function for validating a date, but that's not needed by this particular script. If you want to change the validation process on the server, you would need to either edit or add the element that you want to check at this point so that the form error array is present. You would need to create a type of match regular expression. If it's false, set the error message for your form element's ID or name. And if that's done, valid is false, everything is sent back to the user. Our script select row to edit also contains variables that are specific to the ID of the form elements that we're using. It starts by checking to see if our web data array contains anything. So this particular construct is saying, is it true or false that our array web data contains any information? So if it's not empty, we can then go ahead and do our sort. We'll set the sort direction first of all to ascending, but if it's set in web data to descending, then we will set sort direction equal to descending. Note that we do not use any values from the form directly in the SQL. This prevents injection attacks. So we'll set sort by to be last name. If sort by has been set by the web data to equal first name, we will set sort by to be first name. If the web data sort by is equal to email, I should say equivalent to email, sort by is email. So note we're not using values directly. Then we're going to set our search terms. We're going to create a variable that starts with the percentage character, and that in SQL will mean anything up to that point, followed by the web data item for search column first name, followed by another %, which means anything after that value. So anything that contains the search term within the first name will be located by SQL. And we're following the same procedure for each of these elements. So the search can be anything, any pattern of characters or numbers within that field will be located by this search. Then we set up the SQL. So note that if you are making changes to the form, you'll need to make changes to sort by, if you want it to be used in the ordering of the sort, you'll need to make changes in this section to adapt to your new element, and you will need to make changes in the SQL here to identify, to extract your data from the table in the database. What you're selecting from the database depends on the data that has been returned. If the search is on an ID, we only search on that ID because an ID can only be one item. But otherwise, we will select all the columns from our table where first name, like question mark. So we're using our prepared parameters again. And again, you'll need to change this if you want to change the form input elements. The binding of parameters again matches the number of elements in our query. So if we're using the ID, we've just got 1S, that's the value that we'll use. If we've got first name, last name, email and telephone, if we've got 1, 2, 3, 4 elements there, we've got 4 S's here because we're using strings for all of these, and then the 4 values that will be used. So again, every time that you see the table elements being identified and you want to make a change to the table, you'll need to make a change to the line. A quick way of doing that is to load all the files that are being used by this particular application into your editor, and most editors will allow you to search all those files, and you can search them for all occurrences of an element name. You could search for all occurrences of first name, you could search for all occurrences of telephone, and that will tell you in which files you need to look for information and to edit that is specific to the particular form that you're using. So here we're executing the statement that we prepared, and we're iterating through each row of the result, again using an associative array, and that allows us to use the name of the element, or the column name in this particular case, to identify the element when we use it to put within the form. Each form has got some hidden elements. The hidden element here is the ID. The action is to edit. The submit has a value that also is the row ID. Now remember what we said before, in a real situation you would not simply provide the ID, you would provide a hash plus salt of the ID as a hidden field, and if that hash plus salt doesn't match the ID here, you would reject it. The hash plus salt cannot easily be counterfeited by a hacker. The hash plus salt is created here on the server. The Block 2 Part 6 solution files are available to you from the module website. I'm Peter Thompson. I hope you found that tutorial to be of use. Thank you for watching.